In engineering, what happens is, you take a practical problem like a bolted joint, which is one of the practical examples I present in the course, and you want to know what is the margin of safety of your joint, or what is the gap that opens up so that you don't want to have gas escaping from that joint. You can construct a mathematical model to it based on the physics and the math, and you get a mathematical model that is very complex, and you cannot solve it without the software tool. And that's what you do in engineering, right? You have these problems, and you use the software tool to solve these mathematical models. Now, if I bring it into the course, I can solve these complex mathematical models using the tool. Usually, we avoid these complex mathematical models because it's like, we can't solve it. So what's the point in talking to, telling students about it? So I was able to bring in these complex mathematical models. The other advantage of using simulation software is that you can visualize the results. And that's a great way to kind of build intuition, understand what's going on, because the software, you can make apparent things such as fluid flow, which you cannot see, or, so you can bring out, like, what is the physical principles, that are embedded in the equations or in the solution and so on. So that way also it's a very effective teaching tool. And it's also a practical skill that, employers are really looking for, and universities are struggling to teach, because you cannot integrate the simulation tool into a conventional kind of classroom. Whereas online learning, it's natural. You're already at the computer, launch the tool, and solve your mathematical model, and look at your practical application.